Post key for this. I'll post the video for this if you're needing help with stuff. So with these rational equations, there were two main types to those that we did. So there's the ones like 1, 2, and 3, where it's just a cross multiplication problem to go after, and then there's problems like 4 and so on, where you need to use the LCD to help you move along there. We do need to check for those extraneous solutions. And we had, talked about extraneous solutions with the root functions and how, when you square both sides, how it can, hide a negative, and so it was okay to end up with like 5 and -5. That was okay. Then we went on to talk about the extraneous solutions here, and it seems like a lot of you guys had trouble letting go of that idea that extraneous solutions are only about negatives, only about the sign, when in this case, with these types of problems, extraneous solutions have nothing to do with the signs, but purely about what's going on with the denominator. So we might plug in a value and end up with like 5/0 equals 2/7, and then be able to say that that's actually okay. It's not our fault that this became 0, and we can't divide by 0. So even though we end up with this not true equation, it's okay. Or you might end up with something like 1/2 plus 3/0 equals 9/0 or something like that. But again, that's not our issue to deal with. It's just that the denominator became 0, which is not okay, but wasn't our fault. What we do want is like 1/4 equals 1/4, or 2/7 equals 2/7. Like those are true statements. That's where we want to end up. But it has nothing to do with signs. Like if the signs are off, then something's wrong. So we'll be checking our answers here. So with the problem like 4, we want to take advantage of the least common denominator in order to get rid of those denominators. All right, that either type of problem we're looking at, whether it's a simple one like number 2 or a more complex one like number 4, our first mini sub goal should be to get rid of the denominators. And with the problem like 4, we want to say, well, what if I'd had like 1/2 plus x/5 equals 9? Like you say, well, how do I get rid of a 2? Okay, let's just multiply everything by 2. Or how do I get rid of a 5? Let's multiply everything by 5. Well, if I want to get rid of that 2 and the 5 at the same time, well, 2 times 5 is 10. I can just multiply everything by 10. Well, it's kind of the same idea here with these. Like if I want to get rid of an x, I would just multiply by x. If I want to get rid of an x plus 4, I would multiply by x plus 4. What we need to be able to be okay with is that x and x plus 4 actually don't have anything in common. When we think about it in a multiplication way, there's nothing in common. There's nothing I can multiply x by to get x plus 4, and there's nothing I can multiply x plus 4 by to get x. So if we're looking for that least common denominator, it's just their product. So we're going to multiply every term by x and x plus 4. And I just recommend to you guys that when you're doing this, don't distribute that. It actually makes the problem harder when you do the distribution there. So really don't do that. But we keep the why in mind and help us with the how. Our goal, our first sub goal here is to get the denominators to cancel, get those fractions to go away. So we see that the x's would cancel here, and we'd be left with the x minus 2 times x plus 4. So those will need to FOIL out or double distribute out. And so we'd end up with x squared plus 4x minus 2x minus 8, which can be simplified down to x squared plus 2x minus 8. On the next term, the x plus 4's cancel, so we're left with just the 7 and the x. So 7x comes down, and as I'm bringing stuff down, just put it in parentheses. And sometimes the parentheses matter, and sometimes they don't. And then the last one, the x plus 4's cancel again. We're left with 2 in the x here, so just 2x. So we do have some like terms here on the left side we need to combine. So I get x squared, 2x minus 7x would be negative 5x. And then we'll bring that 2x over. So x squared minus 7x minus 8 equals 0. And I did get that right side to be 0 because I have x's and x squared. So factoring to solve this is going to be the appropriate way. We talked about factoring a little bit on Friday again. When you have x squareds and x's, you're going to factor that in order to solve it. So now that we're ready to factor, what question should we be asking ourselves? Okay, is there one? Okay, so what's next? What's next in the, so no GCFs, what's next in the question line then, Caleb? Okay, so what should we be asking yourself if we're going to do AC method? Yeah, so our AC is negative 8. And we want that to add to what? Negative 7, right? So what factors of negative 8 add to be negative 7? Factors of negative 8 add to be negative 7. Negative 8 and positive 1, yeah, Brad? So we get x squared minus 8x plus 1x minus 8 equals 0. Break that in half. Those first two both have an x in them, x times x, and x times negative 8. Next two just have a 1 in common, so bring out a positive 1 times x and times negative 8. So we end up with x minus 8 times x plus 1. And we could have done the shorter version of AC method. We didn't talk about that much. Because a was 1, we could have jumped straight to here. But I don't really think a lot of you guys would remember that, but it is a shortcut you can take advantage of if a is 1. So x would be positive 8, and x would be negative 1.
So if I did
You're talking about going from right here? Yeah, what I'd expect to see, Brian, would be, basically you're thinking, like, here's my problem, here's what my thinking was, what are my factors of negative 8 that had to be negative 7? Well, I need these numbers, and then here they are, right? So, yeah, that's fine to do. You don't need to do those middle two steps. So we do need to check both of those. They should both at least work. Like, neither one of them is going to give us a 0 in the bottom, so it doesn't mean they're right, but they at least have a shot at working. Because plugging 8 into either of these is not going to make the denominator 0. Plugging negative 1 into either of these is not going to make the denominator 0. So it doesn't mean they're right, but they have an opportunity to work. And I know one of the checks here particularly is kind of a weird situation. We made sure that the problem on the final is a little bit neater. But checking 8, 8 minus 2 is 6 over 8. And minus 7 over 8 plus 4, which would be 12, equals 2 over 8 plus 4, which would be 12. So if you notice here, the 7/12 will not reduce, whereas the other ones will. So I need to get the other ones that have denominators of 12 in order to look at this math. And this one's already at 12, so I don't need to worry about this. I need to figure out how to get this to be a 12. That's a little weird. If I take that down to 3/4, then I can bring it back up to 12s. So 6/8 is equal to 3/4, which then I can multiply by 3 and 3. Get 9 12s minus 7 12s, which would be 2 12s. Yeah, the 8 just had a little bit of a weird check to it. Plugging in -1, -1 minus 2 is -3, over -1 minus 7, -1 plus 4 is +3. So I get 3 minus 7/3 equals 2/3. So how many thirds are in 3? How many thirds are in 3? Yep. Jared, how many thirds are in 1? How many thirds are in 1, Jarrett? How many halves are in 1, Jarrett? There you go. Yep. So how many thirds are in 3? There's 3 thirds in 1. How many thirds are in 3? There you go. So 9 thirds minus 7 thirds, which of course is 2 thirds. But definitely expect to see a little bit of factoring on the final. Again, one of the big skills we wanted you guys walking out of this class knowing. So definitely see a little bit. We saw a little bit Friday, a little bit today. Sam, you want to do 1, 2, or 3? So apparently I screwed up 3 somehow. I've not had time to go back and figure out what I did wrong, but it doesn't actually end up being solvable, but it's good to see what we should do just to start the problem. It is solvable, just not in a very neat way. So all these 1, 2, and 3 are just cross multiplication problems. When you have a fraction equals a fraction, just cross multiply. So of course 3 times x minus 6 will just be 3x minus 18. And then when you go through and do the FOIL on the x minus 4 times x plus 9, you end up with x squared plus 5x minus 36 once you work it all out. And very similarly to the last problem, right, we have squares and x's. So gather all those things onto one side and make the other side 0. So always move things towards the x squared. So I'm going to move 3x over. So we end up with 0 equals x squared plus 2x plus 18. Is that? Yeah. You want one side to be 0. Thanks, Mason. And at this point, we should be doing the AC method again, but this is where this problem falls apart because it's not actually factorable. So I mistyped something or messed something up. So factors of -18 that add to be 2, they don't exist. So if you were going to solve this, you'd have to use the quadratic formula, and we certainly aren't asking you guys to do that on the final. So I made some sort of mistake here. It does have answers, but they're either not real or irrational. Something's going on. But that was the idea behind that one. You should cross multiply, gather everything to one side, factor if you could. So like 1 and 2 should be really simple. We can come back and look at more later if you guys want after we look at the other stuff. Yeah, there's just a whole bunch of problems there if you need to practice. Not telling you guys need to do all those. After that, looking at the systems of equations, this stuff really should be so much simpler than pretty much everything else we've looked at this semester. This is really something you usually would do first semester but since we want to integrate it with the matrix stuff, put it back at the back end. So just remember with systems of equations, you have your two main methods of solving, which was our substitution method and then the elimination method. And when you're after the substitution method, what you're looking for ideally is for one of the equations to be solved already for one of the variables. So looking at a problem like 10 or 11, where one of those variables is already solved for, it's really just screaming at you like, use substitution on me, it'll be easy. And then 13's almost solved for, like that y is almost by itself. So it'd be pretty easy to do substitution on 13 as well. Okay? But not as ideal as 10 or 11. Elimination, that's where you generally want the variables to be on the same side, in that standard form. So 12, 14, those are really set up very well for elimination method for you. Number 9 is very well, easily elimination method. So this is what are you looking for? Again, those are just options. You can do any of these problems with either method. It's just about which way is the easiest is really the thought there. So just recognizing it for what it is. And so far people have had questions today, like if I'm going to ask you guys to use a certain method or not. There's only going to be 15 questions on the final. And so we won't have time to do like 3 of each of these or whatever like that. So have you guys try this method, try that method. So it's really just going to do whatever method you want. And just, FYI, we're going to give you guys that 70 minutes or whatever, and that's the time you get. Like, we're not doing extra time on those. So you can't do 15 problems in 70 minutes, then too bad. So plugging the expression in to the other equation, do a little bit of distribution. So I'm going to distribute that -3. So 2x plus 3x plus 18. Now here we have just x's. So we want to have x's on one side and then the numbers on the other side. So I've got some like terms to combine here. And then I'm going to kick the 18 to the right. Why am I distributing? Because I have to? Plugging that into there. So we got 5x equals -20. So x must be -4. Once you know what x is, plug in, find y. You can use either equation you want. I would use the second one. So y equals -4 minus 6. So that's 4 minus 6, which is -2. Did I ask you guys to write your answers in ordered pair? So that would be -4, -2. Then you do need to check your answer in both equations. I think that was one of the things I was kind of surprised by on this quiz, is how often people were not doing that, checking their answers in both equations. That's the whole point of this, is making sure that point is on both lines. It's really easy to find a point on one of the lines and not the other, and not know that you've made a mistake. So you do need to check both answers. So 2 times -4 minus 3 times -2 is supposed to be -2. It does seem like you guys have gotten a lot better about not solving when you're checking though, so that's good. So we get -8 plus 6, which is -2. So just simplifying the side down. And check the other one, -2 equals -4 minus 6. So that'll both work. So there's a pretty typical example of a substitution method problem. If we look down at 14, there's again, pretty typical elimination method problem. We want the variables to have opposite coefficients. So here I see a 16 and an 8. It's like, oh, if they're both, negative 16 and a positive 16, I could cancel those. Or if I had a negative 2 and a positive 2, I could cancel those. So you kind of pick you want to deal with. So I'm going to say I want to try to get those y's to cancel. So I'm going to turn that into a negative 2. So distribute that through. So I had 16y minus 16x minus 2y equals 6. Negative 16x plus 2y. And when you add down, you should notice actually the x's cancel to 0, y's cancel to 0. You 0 plus 0 equals 10. So 0 equals 10. Yeah, right on Mason, that means no solutions. So I've had people say extraneous. I've had people today say undefined. Those are not the correct terms for this. Undefined is when we say when we're talking about division by 0. Extraneous is an answer that you got. You plug it back in and it doesn't work. We're not getting an answer here. We're getting this false statement. So remember what we just found on number 10 or whatever that was, we found the point where the lines cross. Here we're seeing that the lines don't cross. So these are these parallel lines. And the other situation is if you end up with a true statement, 10 equals 10, 0 equals 0. That's our infinite solutions situation where the lines are on top of each other.
So,
I'm just looking and saying, well, if I could get these y's to cancel, if I had 2 y's, then I'd want to add it to negative 2 y's to make them go away. So just trying to say, what number would I want to multiply by to get this coefficient here to cancel that coefficient? So how can I manipulate this y term to cancel that y term? That's what I decided to do. So if you get a true statement, that's your infinite solutions. That's where the lines are right on top of each other. I have had people say that's like all real numbers, which it's not. All real numbers would imply that every number works, every point works. This is not the case. It's only the points that are on those lines work. There are many, many other points that are not on those lines. So there are infinite solutions, but there are still way more answers that don't work than do. So all real numbers is not the correct term there. So there's a couple examples of systems of equations, which again should be much simpler than most of the stuff we've done this semester. And the last thing was the real simple matrix operations. We took away, we're not going to ask you guys to multiply like matrix times matrix. We're not going to ask you guys to do row operations. That's not something we expected you guys to master. That's why we had you guys do it on the calculator in the end. We expect that you should be able to master the scalar multiplication, the addition, subtraction of matrices when possible. So how do we know when we can add or subtract matrices? What are we looking for? Kim? Yeah, they have to be the same dimensions, just straight up the same. With the multiplication, there was like that weird kind of manipulation we had to do to say that they were, we can do it. This is just straight up the same size. So is there one there we can't do, Kel?
we
Can't do B? Is there any other ones we can't do there? Can't do E. Yeah. So those are the two there that aren't doable. Okay? A is just subtraction. Here I got some scalar multiplication with some subtraction. Scalar multiplication, addition, subtraction. I think the main thing I'd want you guys to watch out for when you do a problem like C or like E down there, you just need to make a decision about this number here. Are you distributing a 3 or are you distributing a negative 3? You just got to make a decision and stick with it. You can't kind of waffle on yourself on that. I prefer just to distribute the positive number and worry about the negative later, the minus sign later. But but it's just, it's just distribution. That's all it is.
We're not going to do so we have columns and also two columns.
It's the other way around, Brian. It's rows and columns, but I mean, it should be pretty obvious that they're the same size or not. Like, those are not the same size. Those are not the same size. Like, that's all you need to worry about, if they're the same size or not. So, for what we're doing here, so that'd be negative 20, 12, 8, negative 28. Then since I'm just going to distribute a positive 3 here, so I'm bringing that minus sign down. So then I get 3, 0, 12, and negative 9. If I had decided to distribute the negative 3 through there, this would need to become a plus sign. And so I have to make a decision and go for it. So if that's a negative 3 I'm distributing, this turns into a plus sign. It's a positive 3 I'm distributing, then the minus sign drops down. And then once I do that, I just need to be really careful about reading to myself. It's just those corresponding elements that we're going to add or subtract. So negative 20 minus 3. Negative 20 minus 3 is negative 23. 8 minus 0 is 8. Doesn't matter what order you do them in. 12 minus 12 is 0. Negative 28 minus negative 9. Negative 28 plus 9 would be negative 19. Just make sure you're reading to yourself really well as you're doing that. This minus this, this minus that. So you get the signs right. But the scalar multiplication, the addition, subtraction, really should be pretty straightforward as long as you guys are paying attention. Should be pretty easy. Any ones on the back you guys want to do? There's some on the front side you guys want to do? We got more time here. Sure. 5 is a good one to look at. So just starting with that first question, should I use LCD? Should I use cross multiplication? So if there's 3 terms you see there, you cannot use the cross multiplication. So we need to think about what's the least common denominator. And then the next thing, kind of like, well, if I'm looking for least common denominator, I want to see, do they have anything in common already? Is there anything I can multiply 2 by to get x? No. Is there anything I multiply x by to get 2? No. So that's really the kind of the best case scenario, I think. If they don't have anything in common, you just multiply by their product. 2 times x is what I'm multiplied by. And again, keep that y in mind to help you with the how. We're doing this to get rid of the denominators. So the 2's will cancel. So that'll leave me with just the 5 and the x. So 5x. X's would cancel. So that's just going to leave me with the 3 and the 2. And then on the right side, there's nothing to cancel, so it's just 3 times 2x. Once you get to that point, it's like, oh yeah, it's an easy equation to solve now. Our first step should always be find a way to get rid of the denominators. Let's use the LCD or use cross multiplication. Now we have a nice, easy equation to solve. So get the x's to the same side. Find out that x is 6. So then checking 6 would be 5 over 2 plus 3 over 6 equals 3. So 5 halves plus 1 half would be 6 halves, which is 3. Other ones you guys want to look at? Kyla, Sophia, Garrett.
See,
Sam, anything you want to do? Anything? Okay, because I'm going to pick one to do. So when you're looking at a problem like 8, so that LCD idea, we got to actually think a little bit harder on this problem because there is a connection between the denominators. 10 and 5 have commonness, right? So there is something I can multiply 5 by to get 10. So I just need to stop and think, what's the least thing I can do here? Now, in the moment I told you guys, if you don't want to stress about finding the least common denominator, you can just find any common denominator, and that'll be a way to move forward on the problem. But if we want to think about what's the smallest thing that both 5 and 10 go into, it's the smallest thing that 5 and 10 both go into. That's the biggest thing that goes into both of them, not what they both go into. Five and 10 both go into 10. So 5x and 10 both go into 10x. So the LCD here is 10x. Again, the common denominator would be 50x. You can use that. We'll have some reducing you'll have to do later. But the least common denominator is 10x. So it's the ideal one, but if you just want to use 50x, you can. It's not going to kill you. Again, if we keep in mind our y, I'm trying to cancel the denominators. That'll help us with the how. So those 10s will cancel, and so I'd be left with the 7 and the x there. On the next one, there's nothing to cancel, so let's get 20x. And on the last one, 5 will cancel with the 10, so leaving me a 2. And then the x's would cancel completely. So I just have this 2 and this 13 left over. So that would give me 26. So like terms on the left side give me negative 13x equals 26. Divide that, you get negative 2. Just seeing that LCD versus any common denominator, again, could just start moving through the problem. So I notice on that right side when I have a tenth, so I have a negative 13 tenths, 7 tenths. So I'm going to turn that negative 2 into tenths. That'd be negative 20 tenths. So 7 minus 20 is negative 13. So negative 13 tenths. Jubal, June, Jalen, Jordan. You guys want to do? Dion? Sure. Which method do you want to use? Elimination, substitution? Okay, so what do we need to do in order to turn this into an elimination problem? What's wrong with it? Something wrong with this right now.
Oh yeah, we need to make it
Yeah. So that 3x needs to come over if we're going to do that.
negative 3. And then
Why do you want to do 3? Yeah, so multiply by -2. It's going to bring that down below. So it's positive 6x minus 4y, positive 20. So when you add down, you get 0 plus 0 equals 0. So there's our infinite solutions type problem. You got it where? Oh, is it here too?
Yeah.
Yep, yeah. Infinite solutions also.
No, the infinite solutions, we obviously check.
You can't really check it because I mean, there's nothing. You don't have any values to check. Basically, what that would mean if you any x value you pick, you have to plug it back in, or y value you pick, you plug it back in and figure out its corresponding y value or its corresponding x value, and then that point should work in both. So if I plug, if I say, well, what if x was 1, and I plug that in, I figure out what the y value for that is. That's a point that's on both lines. If I say, what if x is 7, plug it back in, that point should be on both lines. So you would have to generate x values that you don't have. We don't have anything about x. We don't have anything about y. We'd be generating all those. So, but you couldn't just say that 1/8, 1/8 is a solution. That's not necessarily true. But 1, when I plug it in, will give me an answer, and then that answer should work for both. 2, when I plug it in, will give me an answer. That answer should work in both. But it's not just any random numbers. Okay. Seems like I've taught you guys all I can teach you.